A computer network uses polynomial form for error detection with at bits as information bits and uses x cube plus x plus 1 as the generator polynomial to generate check bits, right? So what is polynomial form? X cube plus x plus 1. So what is your CRC bits? 1 into x cube plus 0 into x square plus 1 into x to the power 1 plus 1 into x to the power 0. So if you are going to see here, 1 0 1 1 1 0 1 1 is your 1 0 1 1 is your CRC generator bits. So your CRC generator bits are 1 0 1 1. So it is of 4 bits. This is of 4 bits. So what is the question? In this network the message will be transmitted as. So we need to figure out CRC bits. And to figure out CRC bits, you know what we need to do. We need to perform XOR operation between CRC generator, that is 1011, and the original data, that is 010 110 11, right? So if I am going to do so, I need to append 3 zeros as of the, because I am having CRC generator 4 bits. I need to append 3 zeros initially at sender's side, and with the help of that I can determine the CRC bits that I need to append. So 1 0 1 1, perform XOR operation. 0 1 is 1, right? And what is our data? Okay, 0 1 is 1, 1 0 is 1, 0 1 is 1, and 1 1 is 0, and rest thing copies as it is 1 0 1 1 0 0 0. Again 1 0 1 1. So 1 1 is 0, 1 0 is 1, 1 1 is 0, 0 1 is 1, 1 0 1 1 0 0 0. Again 1 0 1 1. So here you can say we got the 1 0 1 1, that is 0 0 0 0, and 0 1 1 0 0 0. So let me try to do here. What we are getting right now, all the left side zeros we can ignore, we can skip, no meaning in binary. So 1 1 0 0 0 as a data and 1 0 1 1 as our CRC generator. Perform XOR operation between them. 1 1 is 0, 1 0 is 1, 0 1 is 1, 0 1 is 1 and 0, and then 1 0 1 1. So 1 1 is 0, 1 0 is 1, 1 1 is 0, 0 1 is 1. So you can see that last 3 bits 1 0 1 is going to be work as our CRC generator bits 1 0 1, and 1 0 1 is already, I think, here 101, which we need to append from sender's side, is only visible in option D, which is not visible, I think, which is not visible anywhere else, it is only visible in option D. So option D is the correct sequence of bits. Which sender is going to send from sender side, and receiver is going to receive this if it is going to receive the correct message. So 0 1 0 1 1 0 1 1, it is the original data bits. As you can see, this part is our original data, and we are adding these 3 appended bits as a part of CRC bits. This is called as CRC bits. This 1 0 1, it is CRC bits, which is n minus 1 in length. So there is a 4 bits, which is a length of CRC generator. So CRC bits length is 3. If CRC generator is 10 bits, CRC generator is 10 bits, CRC bits will be of 9. Likewise that. So option D is the correct answer.